Okay, everyone. So this is a demonstration video for lab 5. So in this lab, we are going to practice assembly programming using bit manipulation instructions, which is basically SBI, CBI, SBIS, and SBIC, right? We have covered them in our lecture slides. So the hardware you need is basically the same which you have used in lab 3 with a small addition that you need a push button and you need to connect it with your Arduino, and we are connecting it with the pin 9 on the Arduino board, which is basically port B1, pin 1 of the port B on your microcontroller, right? To understand the mapping between the Arduino board and the microcontroller, you can always refer to the first lecture slide, which is week 0, day 2. So you can go there and look at the mapping table, right? So what we are going to do, so in this lab, what we are going to do is like we are going to connect 3 LEDs, the red LED on pin 8 of the Arduino, green on pin 12, yellow on pin 13, and a push button which is connected with pin 9 of the Arduino board, right? And then what we need to do is that we need to implement this behavior which is shown here in the pseudocode, said that we want to have an infinite finite loop. So what we want to do that when the push button is pressed for the first time, so it turns on the we want to switch on the red LED, and when it is pushed for the second time we want to switch on the green LED. On third push we want the yellow LED to be switched on fourth push of the button we want the red LED to be switched off. On fifth we want green LED to be switched off, and on sixth we want yellow LED to be switched off, and then go back to the start of the loop and keep doing it in infinite loop, right? So before we go and talk about coding and the tasks, let me give you some brief, some background on push button. So the push button here, which we are going to use, is a push button with 4 legs. So let's say we are naming them as leg W, X, Y, and Z. So these legs are like 2 legs are joined together. For example, leg W and leg Y and leg X and leg Z, they are connected with each other, irrespective of whether you push the whether you press the button or not, right? So when you don't uh, push the button, so it is in release form, then uh, the pair of the legs, they are not connected to each other. For example, X and Z are connected to each other, Y and W are connected to each other, but when the push button is released, the two pairs are not connected with each other. However, when you push the button, all the 4 legs are connected with each other, which basically mean that if you voltage apply a voltage level on one leg, you will see the same voltage level on other legs, right? So but the thing is, this is like understanding. But when we look at the push button, right, we don't know that which of the 4 legs make a pair. Like, for example, in case of, for example, when I look at the push button, we don't know which pin is leg X and leg Z, and which two pins are leg W and leg Y, right? But we need to understand that because it is important. For example, why it is important? Because we want to connect our push button in the right way with our pin on the microcontroller. So for example, if I in this figure, for example, if I, let's say I have connected one leg W with the microcontroller, right, and leg Y with the ground signal. So irrespective of whether I push the button or not, my input always will be 0, right? But I don't want that behavior. I want that when I push the button, then the input is 0, and when I don't push, when the button is released, then the input for on the pin is high. So which basically mean is that I want to know that which two legs are connected together. So if 2 legs are connected together, I I connect one of them with the pin on the microcontroller, and a pin from the other pair, for example X and Z, one of them I connect with the ground, right? So also remember we said that if we configure a pin in input mode, so we have the option to enable the internal pull-up registers, right? So let's have a look at this second figure where we have let's say we have the push button in released form, right? So w, leg w and y, it is like connected. We can they are always connected with each other. X and z are always connected with each other. And when on the inside of the AVR, if the pin, let's say pin 0 of the port B is connected as input, so what will happen, and it's in internal pull up register is enabled, so what will happen is that it is connected with VCC through a resistor, right? So the even when we don't push the button, so when the switch is open, even then, because internally it is connected with the VCC, so we will have a logic one in the bit 0 of the pin B register, right? However, if we but note that leg Z is connected with ground. So if we don't press the button, the input is 1 because internally there is a pull-up resistor which gives a logic 1 to the bit 0 of the pin B. However, on this figure on the right side, if we push the button, then what happens that since leg Z is connected with ground, so that ground or logic low appears on the input. So always remember that low voltage level overrides the high voltage level. So although we have VCC coming here, but then it is connected with the ground. So what happens that in the bit 0 of the pin B, we have an input of 0 bit, right? So basically what we are saying here is that when the push button is not pressed, the input will be 1. But when the push button is pressed, then the input will be 0. So basically it's mean that our uh, push button is active low. So when you push it, then the input is 0. When you release it, then input is 1, right? And again, it also highlights why it is important to understand which legs are internally connected with each other. For example, let's say if we misunderstand that, for example, if we connect leg X with the pin B0 and we have ground on leg Z, so irrespective of whether you push the button or not, always you will have an input of 0, and this is not the behavior we want, right? So that's why we need to know which two legs are paired with each other or coupled with each other. And this is the first task which we will be doing in this lab, actually, to figure out that which two legs of the push button are paired with each other, right? So for that, what you need to do is the task A. So actually, I have given you two files, lab5 skeleton.ino and pushbutton.s. So what you need to do is that simply download them, and first you need to basically you need to make the connection just like shown in this figure here. Everything is same as in lab 3, with the only additional thing is that push button is connected with the pin 9 on one side, so here, and on the other side it is connected with ground, right? Note here that it is connected with the ground, which is the same as this black line coming from the ground of the Arduino board, right? So first you need to make all those connections as shown in the figure, and once you are done with that, just download these two files and put them in a new sketch, a new project of the Arduino IDE, and name it as lab 5. And then after that, what you need to do is that you open the skeleton. Let me show you. I have already opened it uh, on my computer. So here you just need, what you need to do is to do the to do one, which is basically just simply call the test push button function, and this function is already implemented for you in the push button.s file. So you don't need to do anything. You just need to call this test push button and call it in the in your .ini file, and when you will call it, so why we are calling it here, actually to figure out that what are the what two pins of the which of the two pins of the push button are by default connected with each other, so that we make the correct connection with the Arduino board. So what does I mean by that? Let me show you. Let me first compile and run the program on my machine, on my microcontroller. So I have, as always, I think it will be a little difficult, but I hope you guys can see my my board, my breadboard, right? I have burnt the program, and now if you see the push button here, uh, let me make the video, uh, maximize the video screen. So if you see the push button, so now this brown cable is connected with the pin 9 on the Arduino board, which is basically pin at index 2, index 1 of the port B, right? So, and I just removed it. So just to demonstrate what I want to do with in this task. The on the other side, I have on the other side of the push button, I have this orange colored jumper cable which connects the one leg of the push button with the ground, right? Now I want to figure out that okay, I have connected this push button, one leg of the push button with the ground. Now the thing is, the code which I have, the function which I have enabled is this, like if I provide an input of 0, all the LEDs will glow on, right? Now remember that there are, on the other side there are two legs. I don't know, let's say if I don't know how to say it, but let's say if I'm naming the pin which is connected with the ground here, the orange which is connected with the orange jumper cable, I'm naming it as, let's say, X, and the one adjacent to it I'm naming it as Y, and one on the opposite side as let's name it as W, and the one adjacent to it as X, one opposite as Y, and then the next one as Z, right? So I want to figure out whether uh, W and X are connected together, or W is connected with Y, or W is connected with Z, right? So how I know if W is connected with Y or not? So if I make a connection with WY and I do not press the push button, and still the controller gets the input value of 0, and it turns out all the LEDs, then it means that W and Y, they are by default connected, all the time connected, right? So it's mean that I need to make this connection which is on the other side connected to the pin 9 of the Arduino board. I need to connect not with the Y but with the Z. So this one is Y, that's only opposite to the, exactly opposite to the W. So let's say that I insert my jumper cable in a hole where Y is connected, right? So if I do that here, so you can see that all the LEDs are switched on, which means that W and X are connected together. So I should not make a connection of the pin 9 of the Arduino board with the pin with the leg Y of the push button, but I should make a connection with the other one, which is basically Z, right? So let me reset my microcontroller, and this time I'm connecting this jumper cable. I'm connecting this cable not with Y but with the Z pin of the Z leg of the micro of the push button. This time when I connect, okay, when I connect, but and now I have not yet pushed the push button. So which means that the input which appears on the pin 9 of the Arduino board is 1. So it is, since it is not 0, that's why the microcontroller will not turn on all the LEDs. But if I press it, then the pin W will be connected, all the four legs will be connected. Remember, W and Y are connected anyways, but the one on the other two, the pair on the other side, on the left side, they are not connected. That pair will be connected with the other pair W, and with the pair of W and uh, Y only when I press the push button. So if I press the push button, you see that all the LEDs are switched on. So this way how you can figure out what is the right way to connect the push button. So that is the first task of the lab, and it carries 15% points.